In order to understand what TCP/IP is, we must first understand the concept of a protocol. Consider the following. Here we see a simplified model of the internet. We see multiple computers in different parts of the world. They are connected by switches. Remember, these switches can only transmit ones and zeros. But we know ones and zeros can be used to transmit letters in the same way that they can store them. Now let's assume we want this computer here in Seattle to talk to this computer in Paris. We want to say a quick hello to the other computer. This, of course, would be done with ones and zeros, but for simplicity's sake, we will use letters. Now here's the problem. We sent hello to the switch, but the switch has no way of knowing where to send it. This is where we create a protocol. In simple terms, the protocol is an agreed upon method of communication. Supposing then that we decide our protocol will be to assign each computer a number, and before each message attach the number of the destination. That is what is done in TCP/IP. In TCP/IP, this number is known as an IP address. So for a simple example in our model, let's assign 1 to Seattle, 2 to Paris, and 3 to Rome. Now supposing Seattle wants to send a message of hello to Paris, it could simply send 2 hello to the switch. The switch would then send it along. This leads us to another problem, however. Let's assume Seattle wants to send this message to Paris. It might send this. However, the switch here doesn't know what to do. Does it send, I just sunk a 3-pointer to Paris? Or does it send, I just sunk A to Paris and pointer to Rome? Therefore, a new part of the protocol is decided upon. We decide that we're going to block everything out in sections of 8 bytes. And the first number will be the destination. Therefore, if we wanted to send, I just sunk a 3-pointer to Paris, we would send it like this, in several sections. You can see this is split into 4 sections. These sections are what are known as packets. Therefore, if we want to change the destination, we will have to start a new packet. Now let's assume that Paris wants to respond back to the sender. Looking at the packet, we can see there is no way to determine who actually sent it. So maybe we change the protocol a bit again, stating that we will put the destination in the first position and the sender in the second position. Also note that these packets are sent separately. There is no way to determine the order in which they will be received. We can solve this as well by putting a number in the third position, stating which order they should go back together so they can be reassembled on the other end in the case they arrive at different times. This is all a very simplified version of TCP/IP. But the idea is not to teach you the TCP/IP protocol, but rather to explain what is actually going on. Here we can see a diagram of the TCP/IP protocol as it actually is. We can see some of the features we have already included in our own unsimplified protocol in this IP packet here. Another takeaway to notice here is how much of what is being transferred is protocol related versus the data you are actually trying to transmit.